All right, everyone. Today, I want you to imagine you're baking cookies. You take them out of the oven, and at first, they are super hot. But after a few minutes, they cool down, right? Now, why does some cookies cool faster than others? Why does the middle part stay warm longer? This is what we call transient heat conduction. It's just a fancy way of saying how things heat up or cool down over time and at different places inside them. So when we talk about steady heat conduction, everything is calm and doesn't change with time. But now, things are changing, like cookies getting colder every minute, or maybe soup getting warmer on the stove. First, let's think about small things, like a tiny metal ball. When you throw it in cold water, it cools really fast. We call this lumped system because it's like the temperature is the same all inside, just going down smoothly with time. It's like if everyone in a classroom leaves at the same speed. The whole class empties at the same time. We can use a simple rule to predict this. There's this number called Biot number, like a magic rule. If it's really small, we can pretend the whole thing cools evenly inside. But if it's big, like with a giant roast, the outside cools, but the inside stays hot, so we can't use the easy rule anymore. Now, if you ever cooked a big piece of meat, you know the middle takes longer to cool down or heat up. That's because heat has to travel from the outside in or inside out. We call this one-dimensional conduction when heat mostly goes in one direction. Like in a wall, heat goes from inside to outside, or in a pipe, it goes from hot water in the middle out to the air. Sometimes it goes in 2 or 3 directions, but we'll keep it simple for now. We can describe how fast something cools using a special time called the time constant. Think of it like how fast it takes for the first big drop in temperature. The more surface area the object has, like lots of skin, the faster it cools. But if it's heavy and thick like a big potato, it takes longer. Then we have fun things called dimensionless numbers. Don't let the name scare you. They're just numbers without units, like a scoreboard. One of them is the Biot number, which tells if heat is having a hard time getting inside the body. If Biot number is low, it's easy for heat to flow inside, and we can use simple math. If it's high, heat has trouble moving inside, and we have to be more careful. Another one is the Fourier number, which is like a clock telling us how much time has passed compared to the size of the object. If we can't use the lumped method, we have to check how temperature changes inside the object over time. Think of cutting open a potato after baking. The outside cools fast, but the inside stays hot longer. Engineers have made formulas for this, but because we like simple things, we usually use charts or tables or just one main term, especially when enough time has passed. Like saying, after 10 minutes, you don't need to count every second, just say it's almost cool. There are special formulas for flat walls, long pipes, and round balls. They all work in similar ways, just changing the shape of the equations. So when you hear the word transient, just think of things cooling or heating up over time and space. When we calculate this, we can know how long it will take to cool a piece of metal, heat up a cup of soup, or even how long a car engine takes to cool after you turn it off. So remember, when you feel the coolness of your soda or the warmth of your food, it's just a heat moving from one place to another, changing with time. And now you understand the story behind it.